minus 5 times 2, which is 2 times 4 minus 10, which is 8 minus 10, which is negative 2. F at negative 1 is 2 times negative 1 squared minus 5 times negative 1, which is 2 times 1 plus 5, which is 7. Fantastic. Now what if instead of substituting a number, I sub in something like 3x? Well, the way that I do the question doesn't change. I still now substitute 3x for wherever I see x. So that's 2 times 3x squared minus 5 times 3x, which is 2 times 9x squared minus 15x, which is 18x squared minus 15x, and you're done the question. That's fantastic. What if I make it a little bit more challenging and I say f at 2x minus 1? Well, that's just 2 times 2x minus 1 squared minus 5 times 2x minus 1. You need to expand the bracket, so if you need to, please write out the middle step, but don't forget the middle term when you FOIL out. That's 2 times 4x squared minus 4x plus 1 minus 10x plus 5, which is 8x squared minus 8x plus 2 minus 10x plus 5. Collect like terms, and you get 8x squared minus 18x plus 7. Fantastic. Not so difficult. Now what if I told you that you actually just did a composite function and you didn't even know it? Well, initially, I asked you to sub in a number. In the last two questions, I actually asked you to sub in a function. A composite function is a function within a function, or a function made up of another function. So you did it, and you didn't even know. So for composite functions, we use a special type of notation. So the best way to read it, instead of just saying f bracket g bracket x bracket bracket, which sounds absolutely absurd, we say f of g of x. So red, it's f of g of x. That's what this stands for. F at g of x. Otherwise known as f of g of x. That's not a dot, it's of. Or sometimes the IB or the textbook really likes to write it this way. A common mistake that students make is that they think this is f of g and they have to multiply by x. That's not the case. Please don't make that mistake. All it means is the same thing as this or this. My personal preference is to use this notation. The IB prefers one of these two. So it really makes no difference, and you can rewrite it any way that you want. So let's try some examples, shall we? The first one says let f of x equal x to the 4 and g of x equal 2x plus 3. Find the following. F of g of x. A good way to break it down is to say f and then sub in g of x, 2x plus 3. That means in the f of x function, wherever I see an x, I'm going to plug in 2x plus 3, exactly like I did up here in this question. So basically, I'm taking the question a step before you've seen it, which just means this is 2x plus 3 to the 4. Fantastic, you're done. Now that you have f of g, notice I want f of g at 3, which means wherever I see an x, I'm going to sub in a 3. That is 2 times 3 plus 3, all to the 4. 2 times 3 is 6, plus 3 is 9, which is 9 to the 4. And you can leave it that way. That's not a problem. The next question says g of f of x, which means g at x to the 4. That's f of x. So wherever I see an x in the g equation, I'm going to sub in x to the 4, which is 2 x to the 4 plus 3. Pretty easy. Now I want g at f at negative 1. Now that I have g of f of x, I can sub in negative 1. So that's 2 negative 1 to the 4 plus 3, which is 2 plus 3, which is 5. Now something students often like to do is mix up the notation. So we're going to show you an example that proves basically that you can't just put one function in another and hope that you're right. So in this question it says f of x is x squared plus 1, which is a parabola that's gone up 1 unit, and I tell you that x is an element of real numbers. G of x is equal to x minus 1, where x is an element of real numbers as well, and this is a line. It says here, does f of g of x equal g of f of x? So let's find them. F of g of x is the same as f at x minus 1. So wherever I see an x, I'm going to sub in x minus 1. So that's x minus 1 squared plus 1. FOIL out, you get x squared minus 2x plus 1 plus another 1, which is x squared minus 2x plus 2. Fantastic. Now do g of f of x. Well, that's g at x squared plus 1. Well, that's just x squared plus 1 minus 1, which is x squared. Notice that these two functions are not the same. So the concluding statement that you need to make is f of g of x is not the same as g of f of x. So be very careful that you're putting the correct function into the other function. Now, it says here, can every function be composed? For example, let's look at this one here, where f of x is equal to x squared, and g of x is equal to root x minus 1. It says find g of f of x. Okay, I can do that. That's the same as g at x squared, which is the square root of x squared minus 1. Then it says evaluate g of f at 0, which is the square root of 0 squared minus 1, which is the square root of negative 1. That doesn't really work. There's a problem there. So what do you think it might be? Give it a thought. Pause the video if you need to before you continue. Then it says, try evaluating f at 0. Okay, I can do that. F at 0 is 0 squared, which is 0. And then find g of f at 0. Well, that means take g and sub in f at 0, which is what I just found. So that's 0 minus 1 all square rooted, which is the square root of negative 1. Notice that I did the same thing two different ways. One way, in A, I found g of f of x, and then I subbed in 0. And the second way was I found f at 0 and subbed that into the g function. Notice the answer is the same. Well, what has to be true in order for a composite function to occur? Well, I don't know if you noticed or you cared to stop and think for a second, but this is a parabola. The domain of this parabola is x is an element of real numbers. This is a square root function. Whatever is underneath the root sign has to be greater than or equal to 0. So x minus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. So if f contains all of the numbers, and g only contains the numbers bigger than or equal to 1, that means the function that I was subbing into g was too big. So in order for composite functions to be true, the domain of the inside function must fit into the domain of the outside function. So in the example that I've given you, f of x is equal to x squared. The domain is x is an element of real numbers. In g of x, x minus 1, x must be greater than or equal to 1. F does not fit into G. The domain of F does not fit into the domain of G. However, the domain of G fits into the domain of F. So I could have found f of g of x. I just can't find g of f of x. Keep that in mind.